Hi folks, welcome to this quick lesson on prerequisite skills for calculus, Math 611B. In this video we'll be looking at factoring sums and difference of cubes, at greatest common factors, and at sometimes called complex fractions or nested fractions. There are also blank notes and filled in notes in the video description, as well as a couple of worksheets for the relevant topics. So the first thing we'll look at is factoring sums and differences of cubes. You already know about factoring differences of squares. A squared minus b squared gives you a plus b, a minus b. There are properties for cubes as well. We've already factored some cubics before. These ones are common enough, though, that maybe you don't want to go through the process of actually using division. Maybe you just want to have a shortcut. So a cubed plus b cubed factors this way. Okay, and we could double check by multiplying it all out and making sure that binomial times that trinomial gives you a cubed plus b cubed. It'll work. Similarly, a cubed minus b cubed works out to this little formula. So if we have a situation here like x cubed minus 8, it's as if our a, or the thing that's cubed first, is x. Okay, x is cubed up front, and our b, well, what is cubed that gives us 8? 8 is 2 cubed. Okay, so really we have x cubed minus 2 cubed. We could think of it that way. Okay. And that would make me think of this one over here in red, the a cubed minus b cubed formula. So it's going to turn into a minus b, so that would be x minus 2. Remember, our a quote is x and our b quote is 2. And then we're going to have a squared, so that's x squared, plus a, which is x, times b, which is 2, plus b squared. Okay, that's a little brackets, so let's see if we can just simplify it out a little bit. X squared plus 2x plus 4. That's a factorization of x cubed minus 8. Now, how do we check to make sure it's right? Well, we could just FOIL it out. Okay, we could go x cubed plus 2x squared plus 4x minus 2x squared. Oh, that looks promising, hey? Minus 2x squared minus 4x, and then finally minus 8. And what will you be left with? Well, these x squareds will go, these 4x's will go. You'll be left with x cubed minus 8. Okay? So it does work out, but the final answer should not be that version where we have all of it expanded again. That's back to where we kind of started from. The final answer should be this factorization here that's in red. Let's try another one. We've got 125 plus 64y cubed. So 125 is 5 cubed. 64y cubed is 4y all cubed. Okay, that's what this really means. So in other words, our sort of a, our first thing that's cubed, is 5. And our b, our second cubed thing that's cubed, is 4y. And we have to recognize them as sums or differences of cubes. So there has to be cubics involved. Let's check this out. We've got a slightly different formula for when we have a sum. It's a plus b, so that would be b, or 5 plus 4y. Okay, times a squared, so that's 5 squared, minus, in this case, a times b plus b squared. Remember, whenever we sub anything in, it's really going in brackets. Okay, so we'd get 5 plus 4y times 25 minus 20y plus 16y squared. And we can double check by FOILing it all out. I think it's going to work here. I think we did things correctly. As long as we choose correctly between sum and difference of cubes, the pluses and minuses will take care of themselves. So we'll do one last one. Here in this one, we've got 16x to the 6th plus 54. Okay, this is question C. So let's check it out here. What cube gives you 16x to the 6th? I don't feel good about this because I can't figure out a number that cubes to give me 16, other than, I guess, the cube root of 16. And I don't know a number that cubes to give me 54. One of the things, though, we need to be aware of is this doesn't replace all of our other stuff that we've learned about factoring. Here, there's a greatest common factor. So take it out first. Do your easy factoring, and then move up. So we always look for a greatest common factor first. And then that starts to make me think, oh, things are looking a little better here. 8x to the 6 is 2 cubed gives you 8. And x squared cubed gives you to the 6. So really this is 2x all squared, all cubed, plus, and this is obviously 3 cubed, the 27. Okay. So in other words, our quote A is 2x squared, and our quote B is 3. Okay. And here was the formula. A cubed plus B cubed equals A plus B by A squared minus AB plus B squared. So let's put it to use. We're still going to have that 2 out front. And we'll have A plus B, so 2x squared plus 3. And then A squared, so that would be 2x squared squared, minus A, which is 2x squared, times B, plus B squared. And these are just techniques that we're going to need to use as we go through some of our limit material. And it's good to have an expanded understanding of what factoring can do, or what some different versions of factoring are. Typically, what you get in the brackets, the trinomial won't be factorable any further. So that's as far as we can go. And again, we can FOIL out to make sure that we're correct. The next thing that we'll look at is complex or nested fractions. So fractions that contain fractions. And really, we already know how to deal with them. So I'm going to do example 2, sort of what I'm going to call the old way. So 2/5 minus 3/4 all over 3. So you'd say, oh, on top, I would like to make a common denominator. So I'm going to times the first one by 4 over 4. And the other one by 5 over 5. And what will that give me? It will give me 8 over 20 minus 15 over 20 all over 3, which is equal to negative 7 over 20 divided by 3, okay, which is equal to negative 7 over 20 divided by 3, like this. And division of fractions means multiplying by the reciprocal. And a final answer of negative 7 over 60. That is perfectly fine. That's a great way to go through this question. I do want to show you another way, though, that is, I think anyways, pretty slick. So this alternate technique involves finding the lowest common denominator of all the nested terms, of all the, let's call them little fractions. So let's see, I've got a little fraction over 5, little fraction over 4. The LCD is going to be 20 in this case. And I'm actually just going to write that as 4 times 5. I'm going to leave it sort of unput together because often when we have algebraic expressions, they'll just be shown factored like that. And what I'm going to do is I'm going to times the top and bottom of this whole big fraction by 20. Okay. So what happens there? If you multiply 2/5 by this whole thing, well, the 5s will divide out, and you'll just be left with 8. Okay, so you'll be out of fraction land. Now, I don't want to show that crossing out because something different is going to cross out in the next one. But the 5s will divide out. I'll just have 2 times 4. I'm going to leave it that way. The 5s will divide out. Minus, let's imagine if I do this piece of multiplication, the 4s will divide out, and I'll be left with negative 3 times 5. And on the bottom, I'll have 3 times 5 times 4. Now, obviously, I could work these out. One of the nice things about this technique is it gets us out of nested fraction land really fast. Because often we get confused by having fractions within fractions, but it's going to happen to us in this course. And then I'd have 8 minus 15 over 60, or negative 7 over 60, with a little less pain, I think. So that sort of idea works for numbers. With numbers, maybe it's not worth the hassle. but often it's very cumbersome to work with nested fractions in algebraic operations. So in B, I'm going to give myself a bit of room here. I'll take a second and just write it out. And there it is. So what I'm wondering here is, what is the lowest common denominator of the little fractions, the little ones on top? And just like in the last one, the lowest common denominator was 5 times 4, or 20. Okay. Here, the lowest common denominator, an easy way to write it is just one of the denominators times the other. And honestly, it's not the end of the world if it's not the lowest common denominator, as long as it's a common denominator. Works better with the lowest, though. So here's what I'm going to do. I'm going to times the top and the bottom of this big fraction by x plus 1. Okay. Now, why is that okay? Because I'm multiplying the top and bottom by the same thing. So that means that it's balanced. I'm secretly just multiplying by 1 here. Also, if it helps you to think of it, that really means that there are little nested fractions here. And I'm kind of, multiplying by that, if that helps. But I want to get out of nested fraction land. So here's the trick. I've written it out. What I'm going to think about is, what if I multiply this first term by all of x by x plus 1? Well, the x plus 1s will divide out, and I'll just be left with 3 times x. So let's show that. I'm going to have 3 times x. Minus, let's repeat, if I did this part and times it by this whole thing, well, the x's would divide out in that case, and I'd have negative 2 by x plus 1. And again, I don't want to actually draw those crossouts because I might forget that I still have to apply them in both cases. Okay, so on top I've got 3 times x minus 2 times x plus 1. On the bottom I've got x by x minus 1 by x plus 1. It's almost never worth expanding out the bottom, okay? Because if it's in factored form, then you might be able to reduce. So what do I have? I have 3x minus 2x minus 2 all over x by x minus 1 by x plus 1. That can be cleaned up just a hair, right? Because 3x minus 2x is just x. And then, so that's x minus 2 over x by x minus 1 by x plus 1. There we go. There's that same fraction written without the nested fractions. And I think that's probably better to have it without the stacked fractions. You cannot divide out those x's. You don't divide out terms, you divide out whole factors. I'm going to make that 2 look a little nicer just so that it's clear in the final version of the notes. So we're going to repeat this one more time for a type of nested fraction that we'll probably see a fair bit of. I'll just write it down. So we look at this question, and I mean, it is what it is. It's annoying that it has 2 variables. But the real thing that we dislike about it is this nested fraction business. So the old style would be that you would times this one by x over x, and this one by x plus h over x plus h, and then you'd have a different nested fraction with common denominators, and things would work out. But I think once you get the hang of this newer to us technique, it will go faster. So the lowest common denominator of those small fractions is just x times x plus h. Okay, it's just one times the other, the exact same way that the lowest common denominator between 5 and 4 was 20, because that's 4 times 5. Okay? It's always going to give us a common denominator, not necessarily the lowest one. So what I'm going to do is I'm going to times the top and bottom of this big fraction by x plus h. And then I start to multiply through. This first term times the whole thing, well, these will divide out. And again, I'm reluctant to actually show that in my final step because I'm worried that I'll forget that I have to multiply by both in everything. But the x plus h's will divide out, and I'll be left with 1 times x. Now the second piece of multiplication, well here, the x's will divide out, and I'll be left with 1 minus 1 by x plus h. And on the bottom, what will I get? Well, I'll get x times h times x plus h. I mean, that really means brackets around each of these, but it's unusual to show brackets around just regular terms. At this point, we can clean up the top a little bit. So we'd have x minus h, and that's over xh by x plus h. Okay, and I can't divide out terms. I have to work it all through and then maybe divide out some factors. So x minus x is 0. On the top, all I'm left with is negative h. On the bottom, I have xh by x plus h. This is the point where true cancellation can happen, or division. All it is division. H divided by h gives you 1. It doesn't give you 0. And that negative is going to stay. So we're going to be left with negative 1 all over x by x plus h, which you could multiply out, but there's no point. And this is all true. That division, that little cancellation can happen as long as h is not 0. Okay? Otherwise, you'd have division by 0, and that's not okay. And a lot of the work that we do in differential calculus is going to hinge on this idea of, well, how close can we make it to 0? But that's a story for another time. So at this point, we have techniques for factoring difference in sums of cubes and for dealing with stacked or nested fractions. There's a worksheet in the video description below. I think it's called Worksheet for Day 1. And that contains some practice questions on exactly this stuff along with answers. I hope that you found this helpful. Good luck with the material, folks, and take care.